Okay, I'm going to kick off. I'm going to give a short talk on the MSc in Electronic and Computer Technology, or as we know it in the school, the MSc in IoT. And then Connor will talk afterwards about the more general Masters in MEng in Electronic and Computer Technology, and that has several majors that you can take as well as part of the program. So that's the order that we're going to go through this talk, and we'll leave some of the questions to the end. So I'll just introduce DCU a little bit, just for those of you who don't know DCU. We're one of the top universities worldwide, in the top 2%, and we're well known in Ireland and with employers in Ireland and across the world. We're ranked first in Ireland and 19th in the world for graduate employment rate. And that's particularly true of, I would say, even more true, if that's such a thing, in the case of the engineering programs, where we've huge demand for our students, our graduates, to be placed in companies around Ireland. And I'll talk a little bit about that in a minute. We're also a young university. Now, universities have been around for centuries. So a young university is a university that's younger than 50 years. So we are around quite a while, but we are still one of the leading young universities in the world. And we have, we've received many awards over the years, including the Times University Year in 2021. We are placed in Dublin, and Dublin is often referred to as the Silicon Valley of Europe. And you can see why when you see an image like this. You can just about see, I don't know, yeah, you can see my cursor. You can see there's a blue arrow there. You can see the airport is up here, and then DCU is here. Dublin is a city of about 1.5 million people. So for international students, that might seem like a small city, but it's a big city in the context of Ireland. And you can see here that it's a big city for companies. You can see everything from Siemens right beside us to, Huawei, to SAS, to PayPal. Intel have a huge presence. IBM have a huge presence. Google, LinkedIn, and if you go even further down south, you can see companies like Vodafone and Microsoft are listed there as well. And these are real presences within Ireland. These are real developer roles. They develop software. They're not call centers for support for products. This is real development work with huge numbers of engineers and computer scientists placed around Ireland. So very good opportunity, especially for international candidates who come onto our programs, where if you get the masters, either of these masters, you're entitled to a 2-year stay-back visa, which is very strong because it means it gives you flexibility to work for who you choose rather than have them arrange a visa on your behalf. So there's huge opportunities in the engineering space, in the IT space, and in the software engineering space within Ireland. And you can see that just from the names that have to be squeezed onto the map there. The school itself hosts these programs. It has been around for quite some time, since the 1980s. I'll just speak for both myself and Connor. We haven't been here since the 1980s. We're more recent additions. But at this stage, we have 27 academic staff and 6 technical support staff within the school. So quite a number of academic staff. These are all research active staff who are working on research, and we'll see later how the research then feeds into our teaching. It feeds into what we do. So the expertise and how we manage to keep these programs current and these courses current is by research. That's what we do. So part of our work is research, part of our work is teaching, and part of our work is administration as well. But the teaching and research piece together coexist, and we couldn't keep our teaching current if all we did was teach. We need to do our research to bring in the best state-of-art work into our modules. We have an engineering building in DCU. It's right on the Collinson's Avenue entrance into DCU, and that's great because it brings everybody together. Like it is the Glasnevin campus is where all of engineering is based. It's a fairly small campus, but it does mean that you're mixing with people that are in different programs across the campus, which is very good. And it's no harm. Talking to engineers is great, but it's also good to get exposed to other programs as well. And as I said, we've research-led teaching and learning. It's really important. Our research is really critical. So for example, I've been doing research in IoT systems and embedded systems, and then that feeds into what I deliver in the modules I deliver on the master's programs and so on. We also have very strong links. We've very industry relevant research, and we have strong links with research with industry. And that's important because that allows us to develop programs that are relevant, that use relevant tools and techniques. We look at these programs as very much applied an application of the theory. We teach the theory, but we very definitely apply everything that we do through assignments and project work. Okay. So to get on to the specific program that I'm going to speak about, which is the MSc program in Electronic and Computer Technology, which is different than the MEng program. I suppose you can take it that the MEng is a more general program. It's with options that you can go into the direction of, whereas the MSc is quite specifically on the sort of the computer is stronger, I think, in terms of the program. That's why it's an MSc, and why when we worked with industry, they saw the MSc as being important to graduates to represent the software and computer nature of the program. So the Internet of Things you've probably heard of the Internet of Things at this stage, but many people speak about it as the next evolution of the Internet. So today we have an Internet of people, largely. If you've seen the Internet emerge over the years, it's gone from kind of an internet of information to a brochureware where you would advertise sales, to sort of a commercial internet where you can buy goods and services, to what it has become now, for the better or worse, which is a social internet, which is where people are using platforms like Twitter and Facebook and so on to share and to share information about their lives. And it's a sort of a person-to-person interaction. The Internet of Things is the next generation of internet, which isn't really something that's going to be about that we're going to be exposed to directly as users of the internet, but it's where, for example, we'll have machines talking to machines and machines interacting with the physical world. So, for example, temperature sensors and light sense switches and light bulbs and motors and controllers, all connected to the internet, making our lives better, recording information about us or about our preferences, and hopefully receding into the background and becoming purely machine-to-machine communications. This will have a big impact on many different sectors. For example, in the areas of, whenever you see the word smart, they typically include some sort of IoT is typically included in some way. So for example, smart traffic management, smart cities for pollution management, traffic control, emergency access, emergency control, industrial internet, industry 4.0. How do we get the maximum from from machines in manufacturing? How do we detect problems that are arising in those machines before the problems have even arisen? Smart grid, how do we manage the energy transfer? How do we work out when is there capacity on the grid to charge our electric vehicles? When can we use the electric vehicle energy to power our homes, for example, in peak energy between 5 and 7? Wearables for measuring our bio information and detecting possibly medical issues with us that we mightn't even be aware of. Maybe even something like a smartwatch can measure can detect arrhythmia and problems with your heart that you mightn't be aware you have. To smart home, to make your home more comfortable, more and connected health. So there's lots of different possible areas that this technology can be applied to. Where we're looking at, I think, in our research, which feeds into our teaching, is we're kind of looking at the next generation of the Internet of Things, which is where we believe that not all the Internet of Things can't be hosted centrally. You can't have 1 billion sensors sending information to a single point, which would be a single point of failure, but also you would need unlimited bandwidth. So we see that edge devices are becoming increasingly important, and the ability to make decisions at the edge of the network is important. So, for example, machine learning on embedded devices at the edge of the Internet of Things is really important. How you manage then the security and how you process data in that way. So we're looking at those challenges as well as part of our programs, and you would be exposed to those through the modules and through project work, for example. So this program was designed in collaboration with industry. It was designed with Intel in particular. We worked with Intel on the topics that needed to be covered as part of this program, what they saw as relevant, and then we obviously had our own ideas. But we worked with industry and with Software SkillNet to develop up a program that was very much identified the skills and the needs of industry, and then we built those into our modules that we delivered, and we developed new modules, particularly around cybersecurity, as well as part of our program, which was seen as critical and presently critical for engineers who are working in the IoT domain. The uniqueness of this program, I think, more than anything else, is that we're looking at the full IoT stack. We're not looking at the cloud engineering alone, or we're not looking at the embedded devices alone. We're doing everything. We're going right from sampling data with modules on DSP and embedded systems, how we connect those devices to a network. We look at the network and what it means to develop a network that's suitable for IoT and for IoT communications, right through to how do we get data. We look at web application, how do we develop applications that allow users to interact with the data or for the data to be stored, right through then to how do we process the data. And we have modules on data analytics and machine learning on how we actually analyze and get value from the data. And we even go into the area of sort of business, where how do we take the ideas that people have generated and turn them into new products or services within a company or within a new company through our entrepreneurship module. So we're looking at the full IoT area as a full stack of different technologies. And if there's one thing you can do when you come out of this program in particular, is that you'll be able to develop a full stack IoT application. That's very much part of your final project as well. The project elements, if you were to compare the differences between the MECE program and the MSc program, the project is the biggest difference. In the case of the MEng program that Connor will talk about, 30 credits is given over to the project. Whereas in the MSc program, we give over 22.5 credits, which is split with formal training for 7.5 credits in project planning and innovation. And then a 15-credit project is then completed over the summer months. So it's a much smaller scale of project, and it's much more specifically tied to IoT in terms of its nature. Ideally, students will come up with their own project ideas and work with either through the different modules, through entrepreneurship, and through their own ideas and their own interests to develop a project that they will deliver then over the summer. As well as everything else, it's a flexible delivery model, which means that we support online students, remote students, and on-campus students. So typically we have on-campus lectures, on-campus activities, but we also support offline learning as well. And that's particularly important for students who are in the industry, for example, who are part-time, who need to travel as part of their work, or if, for example, you had to leave. If you were full-time and you had to leave for a week or two, that's fine. You can continue on. We record lectures and we make them available. And typically all assignments on this program are completable. People can complete them on their own. We provide some electronics equipment, but people can complete them on their own computers. So it means that you're not bound by access to facilities in the university. So here's, I don't have too many more slides, but here's probably a very detailed slide that I can share with you if you email me, and it shows the program structure. Effectively, students have to take 5 modules from this set, plus the project elements at the bottom. And then you have optional modules, which are the green ones over on the left-hand side. Now, the way we see it is that there's essential skills that people need to have on this program. And those are object-oriented programming with embedded systems and mathematical techniques and problem solving. So these are the essential skills. So we provide these to students who need them. If you're coming, for example, from a professional programming background, or you've just done a degree or master's in programming, you might need to take the OOP with embedded systems. So you'd have to satisfy yourself that you've met those criteria. And you could take a different module, for example, in the wireless mobile communications, web application development, or bioelectronics. So students can take up to a maximum of 4 of these 5 modules as part of the program. Then on the right-hand side, these are the core modules that form the major, the major and the program itself. And these would be modules like connected embedded systems, where we develop embedded devices, and typically embedded Linux devices that are able to sense data, develop device drivers, send data to the cloud, and process data through communications, application layer communications frameworks. Real-time DSP is about receiving data in real time and the challenges around that, and how do you process data in time and frequency domain. Data analytics and machine learning is about how do you get information from the data that you've sent, for example, to the cloud. How do you analyze the data and get useful information from it? Or how can you use machine learning techniques to automate the creation of knowledge from the data that you've received? Network stack implementation is about the network and sending data across a network. Security for IoT networks, obviously, is sort of self-explanatory. How do you secure your devices and your network against attack? Blockchain scalability is an option which is becoming important for, especially for sort of agri-food applications or traceability applications and other applications where you need to have some sort of immutable, sort of non-editable ledger of transactions or of events or ingredients or sort of a development cycle. So blockchain is becoming quite important to IoT networks as well. And as I mentioned earlier, entrepreneurship in terms of how do you actually take all the ideas that you get in these lovely technical modules and how do you apply them to a business or to development of your own business, for example. So entrepreneurship is a very much an important part of our program. And interestingly, it was one that Intel pushed very strongly for. They wanted to ensure that when we were developing this program, that their engineers would be able to leverage the knowledge that they had and apply it across Intel's business model. So that was an interesting one. And then the project is at the bottom, and you can see that takes place over the summer. So in terms of the timing, if you come in as a full-time student, it is possible to complete this program in 12 months. So, for example, if you come in full-time in semester 1, which would be September of 2023, and you do let's say four modules in semester 1, you do your exams in December, then you start your next set of modules. You need to do 5 modules in semester 2. This is full-time, which is a heavy workload, but then you would complete those modules in April, May. And then you go on to do your project in June, July, and August. And by completing this, by the following September, you would be complete your assessment, and you would have completed between September 2023 and September 2024. We do offer an entry where it's kind of slipped a bit. I haven't created a separate diagram for this, but it is possible to do a semester 2 entry. We often allow that, where students can come in semester 2, do 4 modules, do the project over the summer, and then follow on with 5 modules in the following semester 1 of the following year. So it is possible to do that as well. The important thing is that students must complete 9 modules plus the project elements, so 90 credits in total. And just to say, this is a fairly full workload. We're squeezing a full master's with, you can see each credit's worth 25 hours of study effectively. That's a combination of lectures, study for exams, study for assignments, and assignment work. We're squeezing that all into 12 months. So it's quite an intensive program, and will involve a lot of work. So it will be difficult to do significant, for example, part-time work alongside this. We do offer a part-time program. It's only available through SkillNet in Ireland, and it's only available to students who are working in industry in Ireland, who are in a SkillNet supported industry. So I can explain that, or I can provide contact details for SkillNet if you intend to apply for the program on a part-time capacity. So what I'm talking about here, the direct entry to DC 896, is a full-time entry only. So just in terms of eligibility, just as my last slide before I hand over to Connor, and this would be pretty consistent between the different programs. The minimum entry requirement is a 2-2 or equivalent in a level 8 primary degree in the computing or engineering or equivalent cognitive discipline. So, for example, a physics domain or or equivalent. Somewhere where you've been in particularly exposed to programming skills and the engineering mathematics skills that will be needed for these programs. As I said, it might be some time since you've been in study, or you might have come through a different system. So the essential skills modules, the programming and the mathematics modules, are there to support your learning, but they're not a replacement for an entire level 8 degree. So that's why we still need that level 8 degree. That's a bachelor's of engineering or a BSc, particularly in computing, would be your entry requirement there. There is a slightly different offering. If you're part-time, you can come in with a slightly different lower onto the qualifier program, which is only available for part-time students and only available through SkillNet. There's no qualifier on the full-time program at present, and just to be clear, it does not meet, a qualifier program would not meet a visa entry requirement for study visa in Ireland, for example. So that's all I'm going to talk about, and clearly I'm available to answer any questions at the end, or as I said, if you don't get a chance to ask them today, please see my email address here. It's just, you can Google me, it's probably the easiest thing. Derek Malloy, DCU, you'll find it's just derek.malloy@dcu.ie. So that's it from me. I'll hand over to Connor, and I'll stay around and answer questions at the end if needed.
Okay, super. Thanks very much, Derek. Let me just share my slides. Okay, great. Well, thanks, Derek. That was a super introduction, I think, to who we are, and everything you said about school and our research, applies across all of our programs. And as you've mentioned, as well as the MSc in IoT, we also offer an MEng program in electronic and computer engineering. So as Derek mentioned, the main difference is that the MEng firstly offers a wider range of modules and major specialties. And the second key difference, as Derek also pointed out, is that the project on the MEng program is a larger project. It's 30 credits as opposed to 15 on the MSc. So it involves more independent research work, generally more design work and more implementation effort over a full 12-month period. So I'll say a little bit more about specifics of the MEng project in a moment. Just give an overview of the program. So it's a full 12-month program when it's taken full time, although we do have part-time options where you can take the program over a longer period of time. And the requirement for the program is to take 8 taught modules plus a project. And we offer the option of specializing in 5 different majors. On each major, there's 4 core modules, plus you would have a free choice of 4 other taught modules, and you'd also do a project specific to your particular major. You also have the option of taking the general masters without a major, and in that case you have a pretty much a free choice of your taught modules and your project topic. So we have currently an offer 30 module options across electronics and computer engineering, network areas, semiconductors to choose from. So there's a very wide choice. So the 5 majors that we offer are major in image processing analysis, major in the Internet of Things, major in nanotechnology and photonics, and 2 network majors at 2 different levels of the network stack, major in future network technologies, which is closer to the physical layer, and major in advanced data networks, which are deals more with the upper layers of networks and network design. So I will give some details of the modules on these majors in a moment, after I've just introduced the overall kind of rationale for the program and its structure if you're taking it full-time or part-time. So the key strengths of the program we would see is that this is a very well-established program. We actually started offering a master's in engineering over 30 years ago, and it was initially developed to align with the needs of industry in the high-tech engineering sector, and that hasn't changed. What has changed is that we continually renew and redevelop the program. So pretty much each year there are new modules introduced onto the program, and all content and modules is kept up to date. But we still have the overall target of producing a program that is very, very relevant to employers in Ireland and abroad. So to do this, to ensure we keep our program up to date, our program, all our programs align very much with our key research expertise. So all module lecturers are involved in research, many of them in national and international research efforts and centres, work on large-scale projects with universities, and also I think it's key to say that most large research projects now must have industry partners. So all of that expertise then is fed back into a program so that students at the master's level can also benefit from from this state-of-the-art knowledge across all the specialties that we have in the school. So the program is also very flexible. So it has a modular structure where you can essentially combine your own selection of modules to really specialize the topics that you're studying. And as I said, you can take the program with one of the specified majors, or you can take it simply as a general master's program where you have a wider choice of selection. So I'm just on the right-hand side of the slide, I've just called out some of the key research centres that the School of Electronic Engineering is involved in. So you can see the range of research expertise that we have across data analytics, photonics, advanced networking, material processing, and plasma in the semiconductor industry, and of course connected embedded systems, edge computing, sensors, networks, and image analysis and processing. So all of these topics are reflected in our research expertise and reflected back into our programs and how we keep them up to date. Because the programs are targeted very much at industry, we find that our graduates have always been in very high demand, and the reasons we see that this is we a very wide-ranging transferable skill set in engineering, system design, implementation, but right through to research and R&D, and looking, to the future, to future technologies and how these will be used in industry. But at the same time, you're specializing, you're gaining, high-tech engineering knowledge across hardware, networks, and software. And as well as gaining knowledge in current and future technologies, you're also getting a very firm foundation in fundamentals, which will remain the fundamentals for all new technologies over the course of a career in engineering. So we think that is very important as well, so that your knowledge and skills are also future proofed. So as I mentioned, the project is a 30 credit project. So that's 1/3 of the credits on the MEng program. So that's really an immersive project. You work with a supervisor, an academic supervisor in the area, but the project is really a self-driven exercise over a long period of time, over 12 months, the full duration of your degree. So this gives you great experience in managing a project right from research through implementation. This really contributes then to the attributes of graduates leaving the program. On the right-hand side, I've just called out some of the companies where students from this program have found employment in the past. I mentioned DCU here as well. The DCU logo is here as well. We've had a number of our master's students come back to DCU and pursue their studies right up to PhD and even continue on to postdoctoral studies. So it just shows the range of the skill set, right from immediately desirable knowledge in industry, right through to skills that allow you to further your studies up to PhD level in engineering. So the program has a number of different entry options, and I'm just summarizing them here. I'll give a little bit more specific detail in a moment. But essentially, you can take the program on a full-time basis, a part-time basis, and you can start the program either in September or in January. We also offer a qualifier program. So if you don't quite meet the entry requirements to enter directly into the MEng, you can first take the qualifier. And that also has full-time and part-time entries in January and in September. So just give some a picture of what the program looks like over the 12 months on the full-time option starting in September. So typically in each semester you'll take 4 modules, or you might take 3 plus 5 depending on the choice of modules you choose. And at the same time in September you start your project, and you'll start with the research phase of the project and discussions with your academic supervisor on the direction of your and design of your project. In semester 2 then you'll move on more to concrete design, and then you have the summer period, a dedicated period over the summer for implementation of the project. So having completed the program, then you'd receive your full transcript of results in November. So that's after we need a period to grade the project, and the graduation ceremony then would be in March of 2025. So just to mention, if you need a parchment earlier than the graduation ceremony, that's no problem. The DCU can provide that to you before graduation. But typically we find it's really the transcript of results that students need, for employment. There's also the option of entering the full-time program in January, so that would extend the period of the program by 6 months. So you would first take taught modules in the second semester, so that would be starting in January, typically 3 or 4 modules. And then in the next academic year, there's nothing in the summer period. There's no formal teaching activities in the summer. You'd come back and you'd take your remaining modules spread over semester 1 and 2 of that year. And again, you'd start the project in September. So all projects start in September, regardless of when you start the program. So that would mean the project would then finish in August of 2025. We also have a very flexible part-time option as well. And this picture shows a typical progression through the part-time program starting in September. So you would take typically 2 modules per semester in each of 4 semesters over 2 academic years. And part-time students don't start their project until the 2nd year. So that's so that they have covered particularly some of the core modules for their majors before they start their project. So it's possible to complete the part-time program starting in September over 2 years. We find that part-time students, particularly students working in industry, they can often choose to extend this out to 3 years, where they might say take their project in the 3rd year, and that can work very well. So it's flexible in terms of which modules you take, their sequencing, and exactly how long you would take on the part-time program. The only limitation is it must be completed over a maximum duration of 4 years. There's also a January entry option as well on the part-time program. So just to point out that if you require a study visa to study in Ireland, if you're coming from abroad, then you can only take the full-time programs in order to get your visa. So the part-time programs are only for students who are already who are your EU status students, or who have already been working in Ireland for some amount of time, so that they don't need a study visa. We also have a qualifier program in case an applicant doesn't quite meet the entry requirements, and I'll call out the entry requirements in a moment. And in this case, you start with by taking 4 modules from the MEng program. So there's exactly the same modules, and you take the modules with MEng students. And once you meet particular requirements for marks on those 4 modules, then that allows you to transfer and take those modules with you onto a full MEng registration in the following year. So we've had quite a few students through this entry route, and they've done very well. So if you don't quite meet the entry requirements, you might consider this option. So I'll just say a little bit about each major. So there are 5 majors, so I'll move through them quite quickly. There is more information online, and of course contact me if you have any specific queries in a particular major. So the image processing and analysis major centers around computer vision, but that also requires skills in data analysis, machine learning, real-time DSP, and it'll be very much backed by software skills as well. So the applications of the knowledge on this program would extend across a range of computer vision areas, from robotics and automation, sensing, image analysis, for example, in the medical domain, where images are processed in order to assist diagnoses, and so on. So the next major, the nanotechnology and photonics major, focuses on semiconductor devices, their design and their manufacture, as well as photonic devices. So photonics and semiconductors more and more becoming more and more interrelated. For example, it'll be be quite common to have optical interconnects between chips in computer systems. Soon, photonics provides very high speed data links between components, not just in the internet over wide areas, but also over short distances between electronic systems. So this major combines nanoelectronics, semiconductors, and photonics in a nice way. So the core modules for the major are on the left, and then you have a choice. You have a free choice, in fact, of the complementary modules. But we will generally recommend complementary modules that particularly if you're coming from an area that was not directly in the area of interest in your major, these modules are a great way to prep you for the more advanced core modules, so that you can transition from your current area of expertise into a new one on a particular major. The major in future network technology. So this is a relatively new major, and this also involves photonics, but more in the application area of networks, and that is also combined with wireless communications as well. So this module covers the key networking technologies for fast interconnection in networks, right from the access, the edge, into core and data center networks, both using radio and optical technology. So this is a very up to date major. Looking at these very fast-growing areas where the need for bandwidth across networks, right from edge to inside data centers and between centers, is continuously growing, and the fundamental technologies, need to be redeveloped to keep up with this demand. The Internet of Things. So as well as the MSc in IoT, the that Derek has described, the dedicated program for IoT. We also offer IoT as an option on the MEng as a major. So I think Derek has given a great description and motivation of what IoT is, and the core technologies that contribute to that. And the same would be true on this major here, and you can see many of the same modules as well. So as I mentioned, the key difference here is that the master's project is a 30 credit project on this program, whereas it's a 15 credit project on the MSc. And finally, we have second data networks major. This major is distinct from the Future Networks Technologies major in that it deals more with higher layers of networks and large-scale network design and network performance. So this would focus, I suppose, more on network operations and network planning, whereas the F&T major is focused more on key future and present network technologies, transmission technologies. So in this major, we have modules that look at the mathematical analysis of networks so that their performance can be predicted and modeled before we build networks to ensure that the network will perform before a network is commissioned. And the complementary modules, feed in here with mathematical techniques and problem solving, which allows you to bring your maths up to speed for these networking analytic kind of topics in the core major, as well as other related modules, very interesting related modules such as security for IoT and edge networks, future networks, architectures, wireless and mobile communications, web app development. So I'll just say a little bit about the project, as it is a third of the MEng program. It's a key element. So you do it over a full 12 months, and the project will be aligned with your major topics. So there'll be a large range of topics posted at the start of the year, and with sets of topics, relevant to different majors, and you have some time to investigate those, talk to the supervisors of the projects to understand what the projects involved will involve. So each project has an academic supervisor who has research expertise in the project area. So they are an expert in the area, and they're there to advise you and guide you through your project. So the output of the project as part of the report is a paper, an academic paper essentially, and the target here is that this would reach a very high academic standards, that it would be publishable. To disseminate your findings, more broadly in conferences potentially. So there's no requirement to publish your work, but we have had quite a few students in the past who were able to bring their work to a standard where they had papers accepted in international conferences. So that just gives you an indication of the level of work that you can achieve from the project. So on the right, I just have an outline of the different deliverables and phases of the project. But generally, you start off researching the area, gaining new knowledge that you need specifically to the project, as well as relating it to knowledge you have picked up in your taught modules. And you produce a literature review first, so that your project is well founded in prior knowledge, that you're applying the most state-of-the-art techniques or extending them in your project. Then you have some time to plan exactly what you're going to do, what you're going to implement in your project, and then over the summer you'll do the actual implementation. So that could mean writing software, simulations, mathematical modeling, using other tools for modeling and analysis, building physical circuits, and so on. And then by August, you're ready to submit your full portfolio. So there are a lot of majors and different modules on the MEng, So I just say, if you're interested in this program, you know, don't worry too much about that, because actually you don't need to choose your modules and your major until registration. If you're thinking of starting the program in September, you do that just a couple of weeks before the start of semester. And we also run comprehensive induction sessions for each program. Derek also runs one for the MSc, of course, and you have a chance in the first week of term to change your mind about the modules that you've registered for too. So there's plenty of time to think about options and to change your mind, you know, after you've sought further information for us once you start the program. Entry requirements and fees. So the entry requirement is the same as for the MSc. So that's a H22 and a level 8 primary honours degree in engineering, computer science, applied physics or related discipline. For the qualifier, a level 8 below H2 or a level 7 qualification in a similar area. With typically, if you have a level 7, we look for additional relevant experience as well. So if you're interested in the qualifier, just get in touch and I can advise what type of experience and qualifications we normally accept on the qualifier. And just point out again that part-time and qualifier students, because these are not full-time programs, these are only available to EU status students. So program fees have here the EU full program fee and the non-EU full program fee. If you're taking the program part-time, then you pay pro rata by the number of credits that you take each year. So DCU also has standard English language requirements. So there is a link here. And application deadlines, so July 1st for non-EU students, 31st July for EU students, and there's full application details links I have here in this slide. So if you need these presentation slides, just get in touch with me so that you have all the links and the information. That's no problem. So if you have any academic questions specifically about the MEng or the qualifier, please don't hesitate to get in touch with me. Here is my email, and Derek has also shared my email in the chat as well. Okay, thank you